Welcome, Dr. James White. I'm really excited to talk to you again. It's been a couple minutes since we last caught up, and dying to hear what you're working on these days. So please, without further ado, please shed the light.
Okay. Well, we are in my lab. We have a number of projects that are ongoing, and of course, we're always interested in rhizophagy cycle and how that process works, and measuring nutrients that rhizophagy cycle brings to plants and that microbes bring to plants. So we're doing that, but we're also looking at how plants actually guide the bacteria into the root tips. And we know there's nutrients there, but we think there also are charges. We can see evidence that there's charges on the tips of roots, and it seems like it is a negative charge on the root tips. And we think that bacteria have a positive charge when they have their nutrients. So there's kind of an electrostatic attraction, right? Electric attractions. This is something in an area that people don't know very much about in terms of how plants work and how plants use these charges. But they actually are quite charged. You've heard about the people use a potato for a battery and stuff like that. So there are these charges in plants, but that may play a role there. Another thing we're working on is we're trying to develop a bioherbicide that's totally edible, and in fact that uses the plant's microbiome to kill weeds. And we're developing. We have prototype now with the U.S. Geological Survey as a collaborator, but this herbicide that we're experimental herbicide that we're working on, bioherbicide, will use amino acids to turn bacterial symbionts into pathogens and kill the plant. So it's manipulating these normally beneficial endophytes in plants to turn them into pathogenic or harmful to the plant. So, but that's ongoing. The other thing that we have that's really interesting is we're working on nitrogen fixing corn. This corn land races that appear to fix nitrogen, compared to commercial cultivars, and that we have a project with Walter Goldstein at the Mandamin Institute in Wisconsin. He's a corn breeder, organic corn breeder, who's been, for the last 10 years, he's been working on this, trying to breed these land races into into cultivars that people can use, especially for organic cultivation, so they don't have to put nitrogen on any of their plants. They don't have to keep putting all the other kind of organic fertilizers on plants. And the thing with that's most interesting is the latest finding is that in this organic corn cultivars, these landrace nitrogen fixing cultivars, the bacteria actually go into and around the chloroplasts. And we think that this is a symbiosis in a symbiosis, that in fact there are bacteria that are symbiotic with the chloroplasts in these plants. And we can use our nitrogen histochemic, our stains that we use to detect nitrogen, and we could see actually nitrate forming in these chloroplasts. And the other thing about the chloroplasts is they don't break down. And so these nitrogen fixing cultivars stay green all the time. And the chloroplasts in these other commercial cultivars, they'll break down and they lose their chlorophyll. They keep recycling what's in the chlorophyll, what's in the chloroplasts. But these nitrogen fixing cultivars don't. They don't recycle it. They keep their green chlorophyll.